Screen, I might not be able to see it.
Hello all, welcome to this presentation on Google BARD Gemini LLM. And we have our AI community researcher, Dulcie, there presenting this. So Dulcie, over to you.
All right. Thank you, Vivek. So, good afternoon from India to everybody who has joined here. A small brief introduction about me. I am a healthcare professional by my bachelor's background. However, I've transitioned into AI and I've been working in AI space for the past 2 years and generative AI for the past around 3-4 months specifically. So today I'm going to be talking about the latest Google Bard Gemini LLM that we've all seen, which was released just about a month ago. So we know to give an overview of how we approach large language models, I wanted to ask questions to our Bard Gemini directly. And as you can see on my screen over here, so there are two things that I want to target over here. What are large language models? Our community very well understands that large language models are these computational architectures where we feed in text data, sequential data, or even other forms or other modalities of data, and we can ask this computational architecture to do multiple things for us. So just not just beyond text, but LLMs can understand images and videos too, as we will see today with the Gemini Pro Vision models, similar to what GPT-4 did, kind of like adapting human-like intelligence. So teaching computers to behave or answer things based off human language, basically. And on this slide, I also want to make a note of one more thing. So over here, what I have sent to the Google Bard Gemini LLM is that what are large language models? Answer in 150 words. So this is one of the major points that we can ask these large language models to devise answers based on what we need. So this is just a small overview of large language models because I don't want to go deep into this, as we'll see what it exactly does overall. I also asked what Gemini models are to the BARD LLM, and this is what the answer I have received. So multiple variants, massive training, multimodal magic, fine-tuning powerhouse. So if we look at the progression of how large language models have evolved, we see that there's a lot of differences in the number of parameters on which these large language models have been trained, the tokens, and the way they are trained, or on the data they are trained, whether it is domain specific or not. But specifically with Gemini models that we are looking into, they're general large language models. They have been trained on huge amount of data from standardized data sets like book corpuses and Wikipedia articles and other structural data. So they adapt to human-like language very easily, especially the way we process language and the way we process images and text. It is the models today that we see in 2024 are adapting much better than the models we saw, let's say 5 years ago also. So just a small overview of the architecture of a large language model. So this is a model by Google. It's an open source model. We don't have the Gemini Ultra as of now, but we do have Gemini Pro and Gemini Pro Vision. So Pro is entirely for text. Its job is to process text data and generate summarization or text generation or any other task that you wanted to do. And Gemini Pro Vision model is kind of like a wrapper around Gemini Pro, where it allows the Gemini Pro to kind of take into account images, videos, other forms of data modalities, different modalities, and encode it so that we can do the task at hand. And a small idea about it, we all know that large language models have evolved from the transformer-based models that were released by Google around 5 years ago. And a small understanding of what these transformer models do, they have separate sections which have areas for encoding, and then there are separate sections which are area for decoding. So encoding would ensure that the input that we send is modified into a way where the LLM can understand whatever the input data that we send, and decoding would actually, the decoder part of the architecture would eventually generate the text or do the task that we want based on our inputs. So how do we build a model? We know we've worked with machine learning algorithms. It's very easy to just apply a machine learning algorithm on a set of data set. But these models, the large language models, are even more complicated and tend to behave like humans in a lot of specific tasks. So how is that achieved? So just a small understanding of the different phases that we see. The phase one is unsupervised learning on standardized data sets, large data sets, millions and billions of parameters on which our large language models are trained. After that, the phase two, where there is a supervised feedback training loop, where only certain specific use cases are supervised so that the model gets better on those specific use cases. And finally, in the phase three, where a human intervention is required, where you kind of tell the a large language model and rank its answers, feed it, give a human feedback, kind of like reinforce the human feedback that the answer that we have received from the LLM, is it correct or not? And this goes on and forth. And finally, when all of these phases are achieved, our output model is ready to launch, like the Gemini BARD or the ChatGPT that we saw. So this is how the phases take place. We take a basic structure of a random model, and then we do a pre-training, generative pre-training phase where unsupervised learning is taking place. And then we do a kind of like a fine-tuning thing where we use specific use cases, and we do supervised feedback training or reinforcement learning through
Yeah,
human
maybe you
feedback.
can kind of increase this, maximize this a little bit. Just Control plus on the Windows will do it.
Okay.
So it's yeah, better, slightly more.
Okay.
Yeah, good now.
This is better.
Yes.
Okay. So, like I was saying, there's another phase where you do a lot of fine tuning. You take specific use cases, and you kind of tell the large language model whether it is doing correctly or not, either through human feedback or through supervised learning, and prompting again and again. And all of these stages keep repeating, and then finally you get the output model. So this is just a crude idea of what we see in large language models. Just a second. Okay. So I'll take us through the PPT first. Just a small section where how does these LLM models understand us? So we have understood the computational architecture. We understand what it's doing, but how does it achieve? How does it behave like a human? Let's assume that it's somewhat closer to behaving like a human in, say, text generation. But how does it do it? One of the major reasons why LLMs behave like human beings in text generation or something text based or something modality based is because of pattern recognition first, statistical associations second. So these models are nothing but mathematical concepts that have been hard encoded in these layers, which kind of learn or track the way you understand text. So one of the ways of understanding the sequence of the text is to encode the positions as well. So transformers and the latest LLMs, of course, have this ability to track the position of the text in a sentence. So if I'm going to say I'm going to the park to meet a friend, earlier it was difficult for the models to earlier models, very early 10 years back or 5 years back models, it was difficult for them to understand, but now they can track the sentence. So I am going to the park to meet a friend. So our current large language models are able to understand that the park and the friend are more important features to focus on, and the position of these words in the sentence, the relative position of these words in the sentence are encoded along with their word embeddings, and then fed into the large language model so that it is able to recognize the pattern and assign, like, do statistical correlations and find probabilities and then predict the next word. Second thing is, because of Sam Altman recently said that there's a new Moore's law coming for generative. The knowledge of the world doubles every 18 months. So given in 2024 we have such access to such amount of data, that these large language models have a lot of data set on which they can train. So lot of data set which has been lot of data that has been generated until now is fed into these large language models. So kind of gives them the ability to track the nuances of the language or the nuances of the features in the input data that we give. And of course, finally, inductive reasoning capabilities would definitely come from the fact that it is able to recognize pattern. It is able to apply mathematical concepts to our data and then generate understanding or some kind of understanding or some kind of broader patterns from the data. So moving on, this is the basic LLM use case categories from an industry point of view. So data transformations, natural language interfaces, workflow automations, co-pilots and assistants. So we can see a lot of places now they have started using chatbot kind of model where the person inside a company can actually talk to this chatbot and talk to the chatbot related to their company's process. So it becomes easy on the employee to understand or quickly look up policies, or maybe quickly look up the workflow or get an understanding of the particular enterprise's work flow or work management, everything. So that is one example that we can see. Another can be taken from a healthcare perspective, that because LLMs and these large language models are like very good at detecting, or because they've been trained on many large amount of data, it is very good at detecting patterns in the data. We can actually employ these large language models to find patterns in medical data that we see. So we might have multiple data, medical patient data, PDFs. We can use these large language models to have a better understanding there. So these are some of the enterprise ways. Now let's move on to the code that I have prepared. So, okay, is everybody able to see?
Yeah, maybe maximize little bit or increase the font. Yeah, better.
Okay. So this is like I'm going to take you through a basic understanding of what these Google Bard Gemini LLM can do. And of course, we can extrapolate these functionalities to bigger and higher projects, complex projects. So the two models that I'll be exploring today are the Gemini Pro and the Pro Vision models. So first of all, I want us to look at the text from text inputs. Me, being from a healthcare background, I asked the Gemini Pro model to answer what is Parkinson's disease. And this is the answer I received. And you can see it is a very detailed answer. But if I ask a similar question to, let's say, GPT 3.5, I might not get such detailed answers on specific questions that are domain specific, if I have to say that.
No, I mean, this Gemini is the latest state-of-the-art LLM from Google.
Yeah.
So
Yes.
this was their attempt to catch up with the GPT-4
GPT.
sophistication from OpenAI.
Yes.
So as per common reports, this Gemini LLM is outperforming GPT-4 in certain areas, but maybe not necessarily all the areas. So what does your research suggest?
So I want to comment on this in the way that the Gemini Pro does a very good job in text generation. Like you can see, it has given a very detailed answer. But the most important thing that I found very interesting was that the Gemini Pro Vision model, the one which takes into account both the image, you can have multimodal inputs. So over here, if I am to show you, I have actually done this. So this is the Gemini Pro Vision model that I have employed. What I'm trying to do over here is that I have taken random images from Google, Google image search, and I have searched these images based on the disease name that I wanted, and I fed these JPEG images to the model along with the prompt saying that, write a short engaging blog post on this picture. It should describe the disease in question, and it has actually done a pretty good job in generating a summary of what the picture says and what is the disease in question. So because it did it for one image, I wanted to see if it is able to do it for other images as well. And so I've kind of
It was able to detect the precise disease
yes
from
sir.
that brain MRI scan. Is that right?
Yes sir. So
So,
JPEG version of the MRI scan actually.
right. So, and it was able to predict the precise disease. And as a medical professional, you can attest to it that this is the
Yes.
disease.
Yes sir.
Okay.
So I pulled out these images from research papers on freely available research papers online. So what happens is a lot of times you can't, of course, report the exact MRI data, but you do put in slices. So this is just a small section of an MRI image, which is imported as a JPEG. And I've asked the model to generate answers. So without the prompt, it tells me what is the MRI sequence. Just give me a moment, it will load over here. But with the prompt, if I write a detailed analysis, so here is the answer for without a prompt, just the image. It tells me the MRI sequence correctly, which is depicted in this image over here.
Can you increase the font again a little bit? Not readable.
Sorry, just a second. Is this
So, what do
visible
you
now?
mean sequence? What do you mean by it generated the sequence?
Sir, MRI sequences are kind of like a process where different types of images are generated. So, when you're looking at different diseases through a magnetic resonance imaging, you have different ways of capturing that image depending on the amount of water content there is in the organ. So, for brain, if you want to see, let's say, if a tumor is there, or if you want to understand if there is some degeneration or some form of trauma to the brain, flare is a very common type of MRI sequence that is used to capture images from the brain, kind of like a human brain, because of the amount of fluid that is there in our brains tissue. So this was something which was very interesting, because of course we need to work further down and see if it is absolutely accurate. But off the top, I used four pictures, four different ways of detecting, and it has done a good job until now. Of course, we can go further down and check in again and again and check, but right now it did a good job from a medical perspective. So this was one thing that I wanted to show. So you can see over here, if I ask it to write a detailed analysis, it has done a good job. It has actually gone into depth, and even given the symptoms, what appears in the disease, what is the reason why the disease happens, and what is the impression of the image as well.
So, you are saying this is without any further
Yeah.
fine tuning or
Yes.
RAG. So, the core Gemini vision model
Yes.
is able to do a very detailed radiological analysis.
Yes, of course. But this is what I have observed. This is what I have observed.
So,
So, of
are we
course.
saying that even radiologists and doctors can be impacted by this technology?
So, yes, if we build on to this, because we have reached a stage where I'm just feeding a JPEG image, things it can do if it is able to detect the actual MRI image. So, I am trying to find a way to kind of like feed the actual MRI image. The biggest thing is that MRI image is usually a four-dimensional array. So our normal images are usually three-dimensional, but it's a four-dimensional array because it's not just a 3D structure, but sometimes it also takes into
Hmm.
account the time that is, captured while taking
Yes,
the
yes,
MRI scan.
yes.
So of course, if we take this LLM and build on top of this, I'm sure automatic detection of the disease while taking the scan in a radiologist chamber is what we are looking for in future or very soon.
Yeah, I
We
think
can,
robotic medical
yeah,
diagnosis is not
right.
very far, it seems. There are
Yeah,
some questions on chat. If you switch to Google
sure.
Chat View, you'll see some questions people have asked.
Just a second. Uh, how factually correct it is, Pratik? Of course, I'll be honest. Like I told you in the beginning, that this is just an understanding what I saw when I was, preparing for this webinar and trying to work around with the Gemini LLM and see what its capabilities are. What happens when it comes to medical data is that there are a lot of stringent laws that are followed in every country related to medical data. So of course, if I go deep into it and ask the LLM to give me exact use case or exact disease and everything about that disease, it probably won't be able to do that. But suppose a student, let's say a college going student is there, and this person wants to understand a disease and it just has a screenshot of that disease. You know how students are usually curious, and he just has a screenshot of the disease. He can get some amount of idea using this functionality. Definitely. But if we want to build a healthcare based product using the Gemini LLM model, of course, you need to, go deep into the analysis and see if every word that they say is correct or not. But what I have fed these four images that I have fed, it has given me a correct answer until now. But of course, if you go from a medical perspective, there's a lot more, work needed to ensure that everything is correct all the time. And the second question, how do we verify if it is not given false info? So to verify this, you'll need a domain specific person to sit and answer. The only reason why I am able to answer this over here today is because I come from a domain in healthcare and I understand neurological diseases, and that's the reason why I'm able to tell the right thing. And the reason why I think this is correct is because I Googled images on the name of their diseases. So the images that you see over here, if it says, ventricles are enlarged, I have actually Googled the image with the disease itself and then fed it to see if it is giving me the right answer or not. So that's how I know that it has given me a factually correct answer, because I Googled multiple sclerosis brain scan JPEG. That's how I got the image over here. So I think Satyajit's answer is also done. From medical images matches how prediction coming from medical images matches with the ground truth. So over here again, I reiterate, these are JPEG images. You will not get always medically factually correct information from JPEG images. The actual understanding of a disease will come from the actual MRI data that we have. But from a general perspective, from a layman's term, or from a person who's not deep into AI, this tool can be a very good tool to kind of like, help in learning, help in education, or help in, providing services. These are very specific things. If you have to go into a medically healthcare domain specific use case, of course, there's a lot of work needed. You can't just take this and say that, okay, I have this, I'm going to use this, just design some specific prompt and I'll get an answer for that. That's not how it will work. We'll need to, further refine the model and, fine tune it to make it more domain specific.
I mean, we are nowhere close to what we call as FDA approval in United States, let's say. So the regulator will not yet approve it, but maybe in couple of years the regulator may
May
pass it. But so far we still need the expert to cross-validate.
Yeah, definitely. And the thing is, there's another question about hallucinations. So I'll be honest, I did not see any hallucinations as of now, and I have not actually sit and really went into depth analysis of every answer. I just wanted to see if it is able to detect the disease correctly in the image or not. That was my main agenda, you know, ki if it is able to understand the disease what I'm showing, and that's what it did. Of course, if I go and read the answers again and again, I might find hallucinations here and there. But the agenda was to see what it can do, what its capabilities are at ground level. We can build on these capabilities and do much more because we already have so much understanding today in just so less prompts, and very generic prompts and very generic things. We have such a depth understanding. I think if we use or leverage these LLMs to build on domain specific use cases, it will probably give us a much better outcome. Definitely. I hope I have answered uh, everyone's. Okay, there's one more. By what measure can we compare the factuality of? Yeah, so I think Oshamya, your answer has been given by Indrajit about evaluation metrics. Okay, so moving on. So like I told you, I used four images. This is a rheumatoid arthritis image that I actually used, and let's see what answer it gives us. So actually, I'd already run this notebook before joining the webinar, and this is what it gave me, a very detailed understanding of what rheumatoid arthritis is. It even gave me radiographic features of RA, inflammation, bone erosion, joint space narrowing. So these are like good. These are like for learning purposes, this is very good from a medical perspective. Did a very good job. This is just a PNG file actually, and not even an actual X-ray file. So let's move on.
So actual X-ray would involve the DICOM image, right? So it's a DICOM format which I saw before, right? Or DICOM, DICOM.
DICOM is for MRI.
Okay, got it.
MRI. So I was actually looking around to see if I could have directly worked with Gemini and a DICOM file, and I was playing around with it, but it needs a lot of pre-processing to be fed into LLM. Like how we know that LLMs are very much trained to understand sequential data, but however these MRI images are four-dimensional photos, so there's a lot of pre-processing needed for it to read the image directly. So that is one use case that we can work on. The some idea about these are the models that were released by Google Generative AI. I've just listed the models over here. So I want to pay attention to one more thing. The latest embedding model on which the Gemini models have been trained, and what do these embeddings do? So I'll take you through that. Okay. So embeddings, we all know from a machine learning perspective or from a AI perspective, we all understand that embeddings are nothing but converting our data into a vector in a mathematical space so that our LLMs can easily track or understand these vectors. So for that, embeddings are required. So there's a latest embedding model, like I mentioned, which was given by Google, and this is the list of content that I passed these embedding models, and see the amount of the mathematical vectors that have been generated because of the embedding model that we have sent. So this was one of the major findings. There's another very interesting feature that has been provided, which is a safety setting where you can actually send a questionable prompt, and the model will itself reply with will tell you that it's not acceptable and I can't answer, or you should seek help. And it will also give you a rating, kind of like a feedback on what four categories of questionable prompts is it on. So over here, it's on sexually explicit prompt. The probability is high. It is giving me the safety ratings. I can bypass these safety ratings as well. So there is a way of bypassing where I can ask the same question and ask it to bypass. But even the Google's documentation says that even if you bypass these safety settings. In most of the cases, the LLM does not respond to your prompt if it sees, if it falls into any of these four categories of, questionable prompts. So that is one thing. Are there any questions?
So one question I had was that Gemini is purely you are calling Gemini as an API. It's not downloadable LLM like Llama 2. Is that right?
Yeah, yes, sir. As of now, I've called an API.
So you didn't find any version of Gemini which is downloadable.
No, sir. I didn't find anything. Maybe it might be there, but I did not get it.
So one mystery for everybody here. I don't know why OpenAI and this Gemini BARD, they are not willing to compete with the downloadable segment, because I guess that you can't monetize it then, because Facebook or Llama has taken the market share or thought leadership in the downloadable LLM, whereas BARD, Gemini, and OpenAI are only giving API-based access. But I guess they are wanting to monetize it, unlike
Yes.
Meta, Llama, which don't care about monetization.
Yeah.
So, one question from my side is Gemini AI is like how we have a open AI, like prompt engineering, we have web sessions like that. Do we have like that other than the coding that what you're doing it?
No, if I understood you correctly, the prompt engineering is what I have done over here by coding and everything. If you're trying to ask me if there's a difference between GPT and Gemini, if
Yeah,
I,
the interface, the web interface in GPT that we have, right? You
yeah,
just type it in the column and it give provide an answer. Whereas
yeah,
I see here that you are using a Python code or something like that,
yes,
and you are doing the prompt engineering over this
yes,
because it is very difficult as like non technical people like comparatively Gemini and Chat GPT.
yeah,
It that's a straightforward for me. Here I have to learn something to code and
good,
ask Gemini to answer it.
yes.
So is it something, is there a way like how ChatGPT is doing it for Gemini so that the
So
non-technical people can easily do it?
So actually, based on my research, Gemini Pro, the functionalities of Gemini Pro has been incorporated in the functionalities of BARD. So BARD received an update as soon as Gemini models were released. But like GPT-4, you can like leverage GPT-4 to, feed multimodal inputs. I haven't seen anything like that for Gemini Pro Vision online, where I can, I don't need to learn code and I can just feed drag and drop my image or any data and get the answer based on that. I've not seen that for Gemini Pro Vision. But for Pro and for text, it has been incorporated in BARD. So like how you talk to ChatGPT, you can talk to BARD in the same way. It did receive an update along the around the same time as, when Gemini models were made public. I hope I've answered your question.
Yeah, thanks. That clarifies me some doubts.
Okay. So let me see if there are any other questions. Uh, can LLM models itself be integrated to CT scan or MRI machine? So, and that would be the ultimate goal. So, my idea is to make sure that, I'm able to feed MRI, CT, PET. So, these are different ways of measuring healthcare organs. These are ways of visualizing organs. So, I want the MRI, PAT, there's a position uh, tomography test, a PET test is done. Diffusion tensor imaging is also done. X-ray, CT, and MRI. So my idea is that one LLM takes into all these five modalities and gives me a final answer, something like that. That would be the ultimate goal. And of course, it's a dream come true for a lot of medical professionals because it becomes very easy for researchers also. So you wouldn't need to be a radiologist to have research in MRI because you have a machine who will understand the data much better than you. It has been trained to understand the data, much better than you. So that's one aspect would be, and it would be really nice if, we work on that in future. Definitely that. How do we validate the confidence on the answers? So of course, there's a lot of lot of downstream processing that needs to be done. Multiple types of prompts have to be given, and then a human who's a domain expert needs to deep dive into every answer and see what is working, what techniques are not working. Also leverage already existing medical GPTs that are there, like BioGPT has a range of models that are trained on biomedical data, apart from the original data that LLMs were trained on. How much is the accuracy in results change if used a DICOM image and repeat the same using a JPEG? So Rudrakant, the accuracy results would definitely change. Plus the amount of information that we'll get from actually feeding a DICOM image to just a JPEG would be a huge difference, because it will, if our models are able to understand MRI, it will be able to tell the doctor that, okay, this part of the brain, this is the name of the part, it is damaged or it is showing some problem. A JPEG image cannot do that because it cannot capture the 3D representation of the brain. So that is one thing.
I have other question about this image scanning.
Yes.
So, like, see now how the data is getting processed. Yes, the question is whether it is getting regionalized or is it going to be a globalized process. Like, for example, if I give the Indian scan image, will that be compared to the other Indians, or is it going to compare with the global Indians for reading the data or for training the data?
So that's actually a very interesting question. The thing is, we have a standard template for our brains. We have a standard template for our brains which are followed everywhere throughout the world. So if I'm sitting in India and I'm analyzing Indian data set, I will use that standard template only. That standard template will tell everybody in this world that, okay, this part of this area is known as this. It will do this. So these standard templates are there for everywhere. What changes from population to population is the size of the brain. So you might have, so if you can see, Africans tend to have larger heads. So not that I'm stereotyping, but they tend to have larger heads. That's what we have observed. But Indians don't have as large heads than them. So there are definitely volumetric changes. Volume might be different, but again, the standard will be same across everywhere. Your brain area of your lobes would be at the same place as mine, just that the volumes would differ. And yeah.
I choose to slightly disagree. So there is a slight difference in propensity for disease, right? Maybe Indian brains have more propensity for neurological disorder compared to African brains or Western brains. So I don't know. So there is
Yes,
some
sir.
genetic
These standards,
predisposition, as well, right?
these standards
Definitely.
are correctable standards, or is it automatic?
I'm sorry, I didn't catch the last question.
The standards template that you're talking about, is it a selectable options, or is it going to be the Gemini will automatically detect from the based on your region, and it will take the templates for
So
training?
we'll have to fine tune the model to understand the standard templates, and the propensity of the disease, like Vivek sir mentioned. There is definitely a difference in the propensity of the disease. See, if we move from a healthcare perspective, there's a lot of things that we can discuss over here. But the idea behind it is that this model at this stage, which is freely available to all of us, especially for at least the AI community that can actually code, basic coding can be done, do prompt engineering or something like that. It can give us these results. So if we use these Gemini LLMs and build on top of it, we will get much better results. And about detecting the standard templates, you'll have to feed the standard templates to the LLM. Definitely that. So fine tuning would be required, where you are using domain specific knowledge to train the LLM, and so that it is able to detect. And these standard templates have already been established a long time ago, is being followed in MATLAB. So the current way of analyzing MRI images is through MATLAB. There's a software called statistical parametric mapping. So the standard templates are already hard encoded, like fed into the software prior. You just have to select the template depending on your requirements. So you can take an average template of like 150 candidates, or you can just take one template of one person from your data set. So that is also there. So if I hope I've answered the questions. Another thing, yes. Yeah, go ahead. Okay, so the other thing is that propensity of disease definitely varies from region to region. Even in India, if you go from JNK to Kerala, you might have a lot of differences based on our genetic makeup and our ancestral lines. But that does not change the standard template of our brain. Frontal lobe of our brain will stay in the front of the brain. Occipital lobe will stay at the back. Frontal lobe will make decisions. Occipital lobe will analyze images. So these are all standardized. So even if your brain has more propensity for disease, it won't change the structure. So your structure won't be different. Your structure will remain same, just the sizes would be different, of course. And of course, the amount of disease or what the kind of disease that you might be more prone to will change. That's the basic idea. I going to share. So then, how would you or any medical body audit an LLM for medical device? So again, I think I won't be the right person to answer how you would audit, because a lot of methods will go into place. A team of researchers from both computer science, AI background, and neuroscience and neurology background, team of radiologists and doctors, a whole team should sit together and go through individual use cases and see what is working and what is not working. So it is a high density project, but at the end of this project, if we find an LLM which can do this for us, then we'll be cutting down on like hours of at least around 3 hours or 4 hours of work every day for every doctor. So that is what we see. A radiologist spends around 4 hours every day writing reports, the kind of reports that I generated by just sending an image as a prompt. So that is one thing. So any other questions if someone wants to discuss anything else? Because this is a basic idea of what these models can do. And yeah, so these are the answers, functionalities. And I, of course, implemented a small rack chain as well to see. So I just want to make a note over here. This is not a right way of, initializing Google API view, but nothing else was working for me. So I initialized it this way. So I sent in mini documents, Gemini. So one sentence mini doc sort of for embedding to see if it is able to, generate answers based on that. So if I ask what is Gemini and pull this method, get relevant documents, it will alter the, sequence in which the documents are there, and it will pick up the document that I need most relevant at top. And if you talk about Gemini Pro, it will pick up the Gemini Pro from Google DeepMind. And if you ask a question, it will, even answer that, Google DeepMind made Gemini Pro. So this was.
So you did a RAG algorithm, but you didn't try fine-tuning technique, right?
No, sir. I didn't try fine-tuning technique because time constraint was also there, and plus I have access to Collab. I had access to Collab only. I didn't have access to Selstrut Hub until then, so I couldn't leverage everything. But yeah, I do have in mind. I've already made a list of a few healthcare-based projects that I would be I would be very interested to show over here also. So these are like open source projects that have been done on machine learning algorithms, but it would be really interesting to adapt these to LLMs or kind of like deep learning techniques, mostly neural networks if we can leverage. So I am thinking of adapting these use cases as well. And there's another use case that I came across, which was able to predict Alzheimer's in a 3D MRI medical image. So this is what we were talking about over here. They have done it on just one area of the brain. I want to extrapolate this reasoning to the entire brain. So it will take a lot of time to pinpoint and iron out all the details. In the interest of the time, I did not get in deep.
One more question. Are you saying that generative AI is better than traditional MLDL techniques for, let's say, variety of radiological situations?
So there's not an easy answer for this. So I'll tell you one thing. LLMs definitely have better capability of understanding patterns in our data. That is for sure. Given the fact that they have been trained on many things and huge amount of data they have already been trained on for such a long time. So traditional machine learning algorithms, they are performed on a single data set. Like, of course, we can build pipelines out of it and deploy and do many other things. But if you look at from, let's say, from this project perspective, we have a set of data. We'll just apply one machine learning model on that set of data, and then we'll get an answer. But what LLMs can do, or basically models like these, deep learning neural networks can do, they can read this data, find patterns, and then successfully actually generalize these things to many other use cases. So you can, like, even though I've trained it on one particular aspect of, I've trained it on medical domain, it can not just answer the diseases, but it will also be able to capture many other understandings, like, diseases, protein specific. So I think your use case would decide which model you want
What
to go
about
for.
there were state-of-the-art computer vision neural networks such as pre-trained ResNet model, a backbone object feature detector, image feature detector. There is also vision transformer, detection
Yes.
transformer. So these were traditional pre-trained neural networks, very sophisticated again. But are we saying this GPT vision or this Gemini vision have made them redundant? Vision
No, sir.
transformer or a detection transformer or ResNet, are all those now redundant?
So, no, sir. They're not redundant. The understanding is that we can leverage these other. So, in my head, it's like one thing can be done good with the vision transformers. They're very good with, detecting whatever images or things, and we can modify vision transformers to detect medical images also. And there are models like that which are actually taking in, MRI medical images directly. The thing is, standalone standalone, if we look at these things, these pre-trained traditional models, these traditional neural networks are good with one thing, but large language models can do many things. The large language model, we can feed a video to it and it still transcribe the video for us, or it can summarize, it can read PDFs, it can read text. If somehow we could leverage this use, or this functionality of LLM, and use, maybe build another structure which can work on similar understanding and similar processes, but leverage medical data or leverage finance data, domain specific data, in accordance with the vision transformers, getting extra insight from vision transformers. Yes, together they can outperform individual traditional models. But redundancy is still not the case, because the traditional models are very domain specific or very use case specific, so they are like very good for that. We can like pull together many different models which are trained on specific use cases and maybe package it together and give an entire functionality. Something like that can be done, but they're not redundant. I wouldn't say they are redundant. In my opinion, they're not. If I have answered. Yes.
Yes, it's quite fair. Thanks.
I'll check in if there are any other questions. Okay. Could you please tell us what is the meaning of RAG and fine tuning? So, Lakshmi, I'll give you one sentence answers. RAG is retrieval augmented generation. What it does, it basically takes external documents, the documents on which this LLM model was not trained. So if I show you a working, so I actually built a project called Chat with PDFs using the Gemini model. So what it does is, over here I have built a project where I am I'll show you. I am submitting PDFs, external PDFs. Okay, these PDFs are converted into chunks. These chunks are then vectorized, and then these vectorized text chunks are sent to the LLM. So these are external documents. This is what RAG does. basically adding on to the knowledge of LLM. Fine tuning, what it does is basically going to the LLM and making changes in the LLM, kind of like adapting it to specific use cases. RAG is nothing but providing extra knowledge so that whatever LLM has learned can be applied through the extra knowledge, augmentation of the knowledge. Whereas fine tuning would mean going back into the training process and changing parameters and working out to adapt it to adapt the LLM itself, the entire structure to a specific use case. I hope I have made myself clear. And is BARD and Gemini same or different? So, well, BARD was the initial model that was released by Google. Gemini has been the latest ones that were given out. They were different models, but Gemini has, to Google, BARD has been updated with Gemini now. So you can say now they are sort of similar, but earlier they were different. And definitely Gemini Pro Vision model is separate from BARD. We can say like that. Is there any quantitative measure of how well the model has been trained given input data? So I think Google has not released the size and the parameters. I mean, I didn't find it. So quantitative measures to understand how well the model has been trained. So again, evaluation metrics and validation testing and a lot of things go into that picture where you understand whether the model is generating the right answer or not. So basically, stage 3, the phase 3 also can be taken into account, where human reinforcement learning is played and human feedback is required. Okay. Someone is asking to share the recording. Definitely that will be done. And I think that's it. I hope I have not missed any questions. That's it from me, Vivek. So should I stop sharing?
Yeah, so you have covered because you are going back and forth between the notebook.
Yeah.
So you have covered the whole notebook, huh?
Yes, sir. I have talked about RAG. I've spoken about the safety ratings and the multimodal. Yeah, I've covered the entire notebook.
So safety rating means there is guardrails built into this model, correct?
Yes, yes.
So
Guardrails.
similar to GPT API as well.
Yes.
Now, let's say I wanted to, and you are saying there's no way to bypass the guardrails.
So they say that there is a way of bypassing, but what I have read in the documentation is that even if you try to bypass it, the model most of the times does not respond to your prompt.
So in your research, how is this model doing compared to GPT API, particularly GPT-4? Because the apple-to-apple comparison would be Gemini with GPT-4, not with GPT 3.5.
Fine. So, sir, I'll be honest over here. I have not had the chance to, work with GPT-4 because it's not open source. So I didn't have access to it. But in my understanding of what it does, I think Gemini is outperforming. The Pro Vision model is outperforming based on what I have found online. People have uploaded results of their questions, their prompts, based on that. Not on my personal use cases, but based on what I found. I think Gemini is outperforming than the GPT-4 model.
I think there are 1 or 2 more questions on Google Chat.
Okay. Yeah, you're welcome, Lakshmi. I'm great that, I'm glad that I'm able to, clear some doubts. You're welcome, Iman. I think so. That's it. There's no other question.
BARD and Gemini are same or different?
I have answered, sir. I think BARD is updated with Gemini, but Gemini Pro is different. It is not in the BARD web interface. It's not there. And someone asked me if there is a limit on how big a training data set can be. So, Shamya, there's a very good paper known as the Chinchilla paper. You can go check it out. So what Chinchilla paper says is that you don't have to, keep increasing the number of tokens or the number of parameters to, get the right output or to get an optimized LLM. You can actually, there's a mathematical relationship between the parameters and tokens that you can, use and follow. to get your answer. So a very good model that actually is optimized according to Chinchilla laws are the BERT model that has been introduced. So you can go read up on that to get more idea about the training and everything. Okay, sir, I'll stop presenting.
Yeah, looks good. Can you share the URL here of the paper?
Just give me a moment.
So meanwhile, I'll answer the question somebody has asked. So if you want to join a research community or Self-Strat AI Lab community, reach out to me. I am the co-founder and lead data scientist. My number I am sharing here. So if you want to join our community for collaborative R&D work, sorry, I'll correct the number. Then do reach out to me, and I'm very active on WhatsApp. Right. So yeah. We can then I can tell you various options of joining our AI research community. We have the parent group, plus we have a product internship program. We have our enterprise level 1, level 2 product internships. Then we have a strategic product team where we are developing our ImagineView LLM platform for business tooling or information mining using GPT. We have many teams for various tasks. So reach out to me on my number if you want to join our community. I'll tell you all the options. And any further questions for Dulcie here? Okay, so I guess excellent presentation. Superb job, Dulcie.
Thank you, sir.
I believe you have a BSc in
Electrophysiology.
So I think that degree combined with your graduate degree in AI ML is a very remarkable combination, and that allows us to see the level of depth on medical diagnosis with LLMs which you are able to present. None of rest of us would be able to talk to the medical things so authoritatively as you are able to. Okay.
Thank you.
Awesome job. Audience, thank you for joining. And Dulcie, look forward to your future presentations.
Thank you, sir, for giving me this opportunity as well. I also learned a lot about Google Bard, and so yeah, all in all, a very good session. Thank you all for